The second gateway is focused on linear equations primarily and on function notation and the connection between functions and graphs. The first problem starts with just a typical graph problem where we have to know that f of 0 notation here. The f of 0 means that the input into the function is 0, and we want to know what the output should be. But remember, points on the graph represent pairs of inputs and the corresponding outputs. So if we know the input is 0, that means we know this first coordinate is 0. So we should find the point on this graph where the first coordinate is 0. It's this one. And the output is the y-coordinate of that point, which is -6. So the answer to this question is -6. We could have been given the output to locate and then ask for the corresponding input. And we'll see a problem like that in just a minute. In this problem, we're asked to find the y-coordinate for a point on the graph. This is really the same question, it's just that now we don't have the graph. Again, we have to know that this is the input, and we're asked for the output. But in function notation, remember that the input is the number that's going to go in place of the letter in this parentheses, and the output is whatever comes out of the equation here. So this question is really asking us to just calculate f of -2. In other words, put -2 for your input and see what your output is. If you do that, you'll see that you get 4 minus 4 plus 4, which is 4. The next problem is the one I was talking about that's written the other way around. It asks for how many solutions does an equation have, but what we have to parse here is that this is saying that the output of the function is -9, and the solution to the equation then will be what the input is. So we're finding out what input will give us an output of -9. Now this question doesn't ask that question. It just asks how many inputs will work. So another question would have been, what are they? And we can certainly answer that too. But this just asks how many there are. So if we're looking for the outputs being -9, remember the output is the y-coordinate. So I'm looking for where this graph has a point whose y-coordinate is -9. -9 is way down here on the y-axis. There's really just the one point right there. So that point has coordinates 2, -9. And so I would conclude that f of 2 equals -9. In other words, this is an input-output pair. Input, output, input, output. So this is the only value on the graph that has a y-coordinate of 9. So the actual input that does this is x equals 2, but the question was how many of these are there? And so there's only one solution. There's one solution. And I could tell you that the solution is x equals 2, if anybody cared. This is a question just using function notation. And we have our friend the absolute value function again. So remember, f of 3 just means replace x with 3 in the equation. So we'll have, oops, let's try that again, absolute value of 10 minus 3. So replacing the x with 3, that's the absolute value of 7, and absolute value of 7 is just 7. Problem 5 asks for where two lines intersect, and this is sort of the easy case where the lines are already solved for y. In other words, both in what we call slope-intercept form. So if our two equations are in slope-intercept form, then we can solve this problem by just setting the two equations equal to each other. And so this is a general way of solving when two anythings intersect. If you have two equations, two graphs that intersect, and they're both written y equals some f of x, then you can just set the f of x and f of x and g of x, or whatever you want to call it, equal to each other and solve. And the reason is that we're trying to find a common point. So if the point is common, that means that the y-coordinate for this line and the y-coordinate for this line coincide. And remember, the equation is literally telling you how the y-coordinate is equal to the x-coordinate. So what you're doing is you're saying, well, if the y-coordinates coincide, then really this y and this y are referring to the same point, the same value y. And if they're the same, then that means we can set them equal to each other and figure out the x. Anyway, so we solve this the normal way. We would add 5x to both sides. And I would get this. So adding 5x to both sides does that. Now adding 3 to both sides gives me this. And lastly, I can multiply both sides by -1, and I get x equals 1. And it's an easy thing to check. If I'm checking, that means I'm putting 1 in for x here. So if I put 1 in for x, I'll have -6 minus 3 equals -9. And if I put 1 in here, I also get y equals -9. So when x is 1, y will be -9 on both lines. It does ask in the problem to find the location of the point, so it wants the answer as a point. So my final answer here would be the point 1, -9.